Hi everyone. This lesson is going to be about identifying outliers in a dataset using the interquartile range. So here's a dataset that looks to be discrete data because there's no decimal values, they're all whole numbers. And so we'll use the interquartile range method on this one. Now I'm going to go straight into stats mode, one variable, and I'll be entering my data. So this will be slightly tedious. Feel free to skip ahead until the end of the data entry. Oh goodness, what happened to OneNote? There it is. I was up to that one. Okay, so now that my data is entered, I'll be using the statistics menu here, Shift 1, and this option number 5 about min and max is where we want to go. Not only does this menu give you the minimum and the maximum, it also gives you the first quartile, median, also called Q2, and the upper quartile, Q3. So let's find the quartiles, shall we? So number 3 gives me Q1, and that equals 9. Let's write that down. Now we'll find the third quartile. Same process. Shift, stats, 5 for min max, and then 5 again for Q3. The upper quartile is 13. Now, the interquartile range is the upper quartile, Q3, subtract the lower quartile, Q1. 13 take 9. Oh, what have I done? 13 take 9 is 4. Now, this is the part where we need to take a look at our QCAA formula sheet, and I'm just going to get that for us to have a look at, and we'll take a look at the formula for interquartile range. So I'll scroll down to the statistics section. Here it is. And here is our rule for outliers using quartiles. So Q1, take 1.5 times the interquartile range, or Q3 plus 1.5 times the interquartile range. So that's all the stuff we need to know. Q1, Q3 and IQR. We already have worked those out over here. So let's go back then and we'll work out Q1 subtract 1.5 times the interquartile range. Our score could be bigger than that, and then Q3 plus 1.5 times the interquartile range. So we'll write some numbers in. Q1 was 9 minus 1.5 times 4, less or equal to the score x. Q3 is 13 plus 1.5, and the interquartile range again is 4. 1.5 times 4 is 6. So that's 3 is less or equal to x, which is less or equal to 19. This number 3 and 19 are sometimes referred to as the fence. Any score in our list which is outside those fences is an outlier. So let's first look Scan through the list for numbers less than 3. Let's see if there's any less than 3. Nope. Now let's check for ones larger than 19. And there's none of those either. So it seems in this data set, all of the individual values lie inside these boundaries or inside the fence. There are no potential outliers in this data set. And that's a valid conclusion as well. If you have to identify potential outliers, sometimes the answer is there are no outliers. Thanks for watching.